Okay, 5, 4.
There we go. Welcome everyone to another episode of Talking Kotlin. My name is still Seb. I'm still your host, and with me today I have, as usual, the man who is also still called Hadi. Hadi, how are you?
I'm good, Seb.
Look at you. You're looking so chipper today. All of a sudden.
I am. I'm. It's good to see you. It's really good to see you.
Yeah, it's been a while. Things are looking different. Our astute viewers will probably see that your room's looking a little different. There's more guitars, less whiskey. What's going on there?
No, my whiskey's there. It's just it's on that side.
Oh, okay.
No, sorry, that side. I got a lot of pushback from people saying every time we watch Talking Kotlin, we think you're an alcoholic. So I had to move my whiskeys over there.
So it's, it's a brand thing.
Well, no, look, true story. What really happened is that like I bought myself another guitar. Okay. Now I got 2 stands on the floor for these guitars and I didn't have space. So I said, you know what? I'm going to hang the guitars. It also looks nice, right? I mean, it looks nice, right?
Yeah, it does.
It does, right?
It does.
And then so I ordered 3 hooks and my guitar. So the 3 hooks came with my guitar. My guitar was broken. And now I just got 3 hooks and 2 hooks and an empty one. So, and no guitar. So there you go. And I'm not going to take that damn thing down anyway. But yeah.
In case that doesn't make sense to our audio listeners, we invite you to tune in on youtube.com/Kotlin.
Yes, to see my guitars.
Yep. Then you'll see what that setup looks like, and you'll see a very sad empty hook to Hadi's right.
Yeah, empty hook, left hook.
Yeah.
Also, you're looking different. You're wearing a hoodie, which probably means that the weather has changed for you drastically.
Oh yeah, it's alternating between like doom and gloom, which is autumn leaves and gray sky, and kind of chipper, pumpkin spice latte season, which is blue sky and autumn trees.
Yeah, so without the pumpkin sky and all of that, it sounds more like the politics in the UK right now. Today was the day that Liz Truss didn't outlast a lettuce, apparently. So I really should have bet on that lettuce.
Man, so this was talking like recap of everything with Kotlin, with the Kotlin people. Now I think it's time we actually introduce a couple of guests.
Wait, I got a whole bag of stuff I want to discuss with you. But
why?
Okay, fine.
Yes,
fine. Okay.
But why don't we do that while the guests are here?
Fine. Okay.
Today on the show we got Christian and Sudarshan from Realm. Hi, folks.
Hello.
Hello.
It's good to see you. Now, first of all, Sudarshan, there's a thing that we just noticed right before we started recording the session. Again, mostly for the people who are watching. You will find me drinking from my cup, which has a Kotlin logo, but it's on this side. I'm right-handed, so I always have to hold the hot side of the cup. And Sudarshan, I think you're in a very similar situation there at MongoDB, huh?
Yeah, I didn't consider this until you mentioned it, but yes, I also have a mug, and I also have the MongoDB logo, but on the wrong side. I think they're built so that I can remind myself where I work when I hold onto this mug with my right hand, but it doesn't really work so well here. I've got to hold onto the hot side if I want you guys to see the logo. So trust me, there's a logo there, but I will be drinking it.
So our audience now is completely confused, right? Because you just introduced our guests as Realm and you're showing a cup on MongoDB. Is there anyone that hasn't heard the news about this?
It's a few years old at this point, but it's still just as exciting as the very first day.
Yeah, I think it's, what is it, 3 years old at this point, I guess, something like that.
Well, I just found out half an hour ago, so, I'm just saying.
I guess we got acquired by MongoDB for like 3 years ago, and I've been working there ever since, and yeah, things are good, I would say, so, yeah.
Nice. And where are you folks located?
I'm currently in SF, but I'm typically based in New York.
Yeah, and I'm in Aarhus in Denmark, so, yeah.
Oh, Aarhus, I've been there.
The original Realm team is all in, or mostly in Europe, and the MongoDB team, at least a lot of us, are in New York. And so it gives us a really good chance to go to Copenhagen for regular offsites and meet the team. It's one of the most fun parts of working with them is going to Copenhagen.
Yeah, Copenhagen's nice, especially war pigs if you like barbecue. I've mentioned that in the past in this episode. I think war pigs. Anyway,
yeah, I think you've mentioned that about 12 times.
yeah, sorry, and Seb always tells me off when I go off topic. So yes, sorry.
No,
sorry,
but
Seb. Sorry.
on the bright side, you took me to war pigs, so it's all fine. It's all good.
Thank you. And then you became a vegetarian. Right. Moving on. Next.
It's news to me. Anyway. So some people, listeners who have been around for a while, actually might remember that this isn't the first time that we're talking to Realm people. In episode 98, I believe, we talked to Nabil and Klaus, who kind of started us off with their journey in Kotlin, and especially in Kotlin Multiplatform, back when the decision was kind of made to make a Kotlin first Realm SDK, especially also with the context of integrating with things like coroutines, flows, and also introducing all of that as a multi-platform thing, right? And as I understand, we've kind of gotten a little bit further in this story, right?
Yeah, you can definitely say that. So since last year, we actually managed to get something done and released. So in the spring, around June, I think, we released our first GA version of the Kotlin Multiplatform SDK. So right now, that is sort of out there, and people seem to be happy with it. And so right now, we're basically building out the features in that. So like for anyone that has been using Realm in the past, like we have a Java SDK that is 7-8 years old at this point. Yeah, so right now we're sort of migrating all the features we want into the pure Kotlin SDK. And yeah, so that I guess that's why we came here, so we can talk about that and maybe show a little bit about how it works. Like we made a bunch of, because Kotlin is so vastly different than Java was in terms of ecosystem and what capabilities you have, we sort of went back and took a look at all the API decisions we made back in the day and sort of took a second look and try to see how would that look like if you thought about Kotlin as a new language and what features you have there. So yeah, I would say we are pretty happy with it, especially like stuff like coroutines, and the threading model is like vastly superior to what we could sort of achieve on Java, and stuff like compiler plugins and the entire thing about how you actually built Kotlin is making a massive difference in terms of what we can actually achieve. And things like extension functions are godsend. If you're building a modular SDK like we are, being able to plug in functionality into APIs is yeah, it's pretty awesome compared to what you can do in Java. So yeah, so I would definitely say we're pretty happy with it, especially now you guys are beta with KMM. Like that was a major headache for our side, trying to figure out the different memory models and supporting all of that. But now we're sort of, okay, now there's one memory model we sort of have to deal with. And so yeah, we're pretty happy right now, I would say.
Nice. That's lovely to hear. So there's a little bit of a specialty in this episode, which is that Christian, I understand you've brought us a bit of a demo, so to speak, to kind of get everyone on the same level here as to where Realm is right now and what kind of fancy things you can do with it. Is that right?
Yeah, that's true. So we thought that the best way to talk about it was maybe to show off what it's actually capable to do, and then we can just take the discussion from there. But yeah, I don't know if I should switch to demo mode or.
Would it be useful to first start by talking about, just quickly describing for listeners what Realm is, Christian?
That might be a good point. I guess for anyone that hadn't heard about us before, so we are an object-oriented database, unlike SQLite, which is like relational. So we represent all our data structures in terms of objects, which is like a pretty massive difference, because that also means that the way you interact with the schema is basically through pure objects. You don't have to think about complicated concepts like joins, stuff like that. That is falling out natively of an object model. So that is, I guess, the biggest difference compared to SQLite, is that you are basically working with objects all the way down, which is has some pretty significant advantages. Also, in terms of we also have this concept called lazy loading, which basically means that is if anyone sort of doing scrolling UIs in Android before knows about the cursor limit and you having to deal with that and trying to fit all of that into memory. That is also a problem we're sort of solving natively, where you basically get access to the underlying memories without having to requery data and stuff like that. So hopefully the idea is that when working with Realm as a database, you should feel like you're just working with your native objects without having to think about a lot of databasey concepts. So yeah,
that brings a lot of good memories up for me after having used it a couple of years ago. It was definitely a good time.
Yeah.
But I think from here it's probably I just want to see the demo now, I'll be honest. So yeah, obviously this is a bit of a crossroads for us, dear listeners, because while the viewers on YouTube, youtube.com/Kotlin, can of course just open their eyes and watch the demo, you in the audio version unfortunately do not have that ability, and probably for safety reasons it might also be better if you're driving, biking, I don't know what you might be doing. So for you folks, that's obviously not gonna work. We're gonna do a bit of a recap of the demo kind of afterwards, so that you hopefully have a good leg to stand on when it comes to the afterwards, the Q&A and the typical talking Kotlin format. But we're just kind of jump over the demo for you folks.
I still think we should become sports commentators, but you don't want to do it.
If you would like to try sport, we can still sports comment. If you want to see our sports commentating, you're also gonna have to tune in on youtube.com/Kotlin. All right,
so
cool. Let's dive in.
So the idea, basically, what we wanted to show you was so basically our syncing solution. So I guess that's one of the main differences after being acquired by MongoDB, is that before doing that, one of our products was this sync solution where we are able to sort of synchronize your Realm databases across a number of devices. We would then handle stuff like conflict resolution, stuff like that for you. Of course, then with being acquired by MongoDB, they had a lot more expertise in actually making things scalable. So that is sort of what that is bringing a lot to the table. So what we have here is basically the combined power of MongoDB on the back end, and then having Kotlin Multiplatform on the front end, where we can use a single code base to basically deploy to a bunch of targets. So right now, the Kotlin Multiplatform SDK supports all the mobile targets, so iOS, Android, but we also support desktop, so either through JVM or through native macOS apps. So that is basically what we have here on the screen. It's those 4 apps sort of running on the same code base, where the only things that actually differ is the UI component. And we'll go back and show the code once we've seen this running. So basically what this is, that you can see it here as I'm doing modifications on one device, it seamlessly propagates to other ones. And here on the server side, we can also see the server isn't as reactive as our front end. So, but if we go in here and modify this, you can hopefully see that this one will also update all the way on the UI. So that means that you sort of have both a way to modify your data on the back end, as well as doing it between devices. And we also have native conflict resolution through a concept called operational transform. Sudarshan can talk in a lot more about that, but that is basically what powers stuff like Google Docs. So like we have, like if you have a bunch of devices going offline, the other ones keep working, and once they sort of go online, they will automatically sort of converge their changes. So if this one is sort of decrementing things, so I guess for the ones not seeing this, you're basically seeing a number of numbers on the screen. We can increment or decrement. So you can see I now have done a bunch of different changes on different devices, and as they go offline, they sort of at some point all converge to sort of the same view of the data, right? And that is what we are basically trying to bring to people, is that doing this sort of logic is pretty hard doing it yourself. So we wanted to make that as easy for people as possible. So that is sort of like what we wanted to do, right? And how does the code for this look like then, right? So if we could jump to Android Studio, let's see. Here, I hope everyone can see this. So if we start by sort of the data model, right? So then we have, as I said, that we just wanted to express our schema as sort of classes. So this is what basically the data model for this simple app, that was just a single class, which contains this counter value down here, which has a concept. So this one is a little bit of a special counter, because it sort of understands that you are adding values to a different or removing values from it. But like you could see any sort of value in here, you can sort of synchronize between devices, right? So the data model is super simple. It's just a single class, and then so this is if you then go to sort of how do you interact with this, then we can see that all that was needed to sort of make this app work was basically what's in this counter repository class here, which is like something like 120 lines of code, most of it's comments, but like basically what you need to do to get this up and running is sort of just log into the server, which is a single line of code running as a suspend function. Then we basically have to define the local database. And this is where right now we are sort of migrating to a new mode of looking at the server data, because the server can have like very large amount of data you might not necessarily want on the clients. So we just recently shipped this new concept called flexible sync, which basically allows you to define the data you want on your device as a set of queries. So you're basically writing queries as you would towards your local database, but those queries are actually being sent to the server, and then that data is being fetched automatically for you and being kept up to date in the background as well. So that is basically what this small configuration object does here. Then we open the realm as a local database, and that is one of the things we really wanted to promote, was this pattern of offline first apps. So that basically means that once you have opened your database, it should feel like you're just working towards a local database. You shouldn't care about doing all of the stuff, talking to the server, doing conflict resolution. All of that is happening behind the scenes. So now we sort of have this Realm instance, which is, I guess, and this is where, for those of you that have used Realm in the past, one of the big complaints we had on the Java SDK was this concept of thread confinement, which basically mirrored the old memory model for Kotlin Multiplatform and native. So like conceptually, it's a very nice module or model, but like a lot of people, it's also tricky to work with if you're not used to that paradigm. So I guess that's also one of the reasons KMM sort of moved into a different model, because yeah, people just have an easier time doing that, and we sort of did the same thing. So in the Kotlin SDK, everything is basically accessible across all the threads. So now we have as a single realm instance, and then we can just use it as you would use a normal object. So writes are basically, we have these write closures that are running as suspend functions, where you update your data, and listening to changes is basically running a query and then asking for a flow on that query. So that means that we are sort of exposing, in our opinion, the native concepts of the Kotlin language. So those are sort of native primitives we're exposing, so people can build on top of those, right? So if you don't like coroutines or flows in your sort of own data layer, like Google has put out extension functions for converting to live data. There's conversions to like RxJava if you want that, to like executors, what have you. Like, but having flows as the basic building block is super powerful. The same with sort of suspend functions. They're also a really good building block, because you can build all kind of other APIs on top of that. But that is basically it, right? So that is the entire sort of code you need to actually have these apps up and running. Of course, you need to build the UI. So I don't think we should show that, but basically, that is also where we can see this convergence of reactive UIs on both the Apple side and the Android side, where Compose is running on both the platforms, or sorry, on desktop and on Android, where you can sort of use the same sort of concepts there to build up your UI, and the same thing is happening on Swift, where you have Swift UI that you can use both on desktop and on your iOS app, right? So this model where like the logic can live inside Kotlin Multiplatform, and then like you actually have to write very little UI code as well on top to sort of share all of this is pretty powerful. So yeah. But yeah, I think that is sort of like, I guess that's also like the thing we really try to accomplish with this, is that like there really shouldn't be much to demo, because like there isn't that much code to care about. So yeah, so basically create your schema as a single class. The only thing is that it sort of extends this realm object interface that gives us a little bit of type safety into our APIs, and in general, you do a write closure on a Realm instance to do writes, to persist them in an asset manner. And then you just run queries and ask for flows for them to get notified about changes. And then you basically have a full reactive UI that is persisted across devices.
The really cool thing that that you mentioned in the beginning that I really love about this is that with very little work, now not only do you have a fully functional mobile app where you're able to interact with your data locally, you didn't really have to think about the database, but with just one extra line of code or one extra configuration piece, you get the entire cloud side of things too, meaning that as a app developer, I can interact with my user data on the cloud side, I can interact it on the mobile device. And then you get this really beautiful conflict resolution where, as you showed, if we're completely still make changes, I can still interact with my app. And then when I come back online, I'm just sort of guaranteed that my changes will be integrated and everyone will end up in the same consistent state. And while you're on this page, it's actually worth showing that we've got a whole bunch of different buttons here. We don't need to click on them, but there's charts at the top. There's GraphQL. There's triggers, which are reactive actions upon when your database receives updates. And so you actually get the full MongoDB offering of all the different app services with your mobile data, which is really hard to do if you don't have something like Sync connecting this to the cloud for you.
Yeah, I think that that was a pretty good explanation. So yeah, so this is a cloud UI where you get all of these different hooks into your local database, right? So yeah.
And we're gonna come back into the audio segment. Would you like to do the recap, or would you like me to try and do the recap for you?
I think you should. This is a quiz for you.
Yeah.
Okay.
Have you been paying attention?
Okay. All right. So quiz for me now is trying to piece back together all the things we've seen. I've made a couple of notes, but excuse me if I don't use the exactly correct terminology, because what started out as this very basic thing of just a couple of counters going up and down actually turned out to be this really interesting demo of synchronizing data from Realm using MongoDB Sync. Do I have that right?
Atlas Device Sync is the official name.
Atlas Device Sync. There we go. I'm sorry. I'm seeing so many MongoDB logos. I'm already indoctrinated, which kind of adds this ability to provide things like native conflict resolution and just kind of sync your state between different devices. We saw, I think I saw some Android there. I saw some iOS there. I saw some Mac OS native, Mac OS JVM, or desktop JVM.
Yes.
Yeah. And of course, we saw a little bit that, as usual with Realm, schemas are classes. The whole app didn't really take much more than roughly 120 lines of code, completely offline first, but then with this little switch you can turn on, and all of a sudden it syncs between the different devices. And of course, kind of really based on top of the very basic principles that we have in Kotlin for concurrency, like flows, suspending functions, and of course the big payoff here being that this being shared code, you would not have to write this multiple times for each platform. You would only have to write it once and then just run it on each target. How was that?
That was pretty good.
That's a solid A+, I would say. So yeah.
Yes, very good. Certified Realm consultant. There we go. Gonna put that on my LinkedIn in the next break.
And one thing that's pretty interesting, you mentioned that offline first, and that's totally true, right? When you're offline, you can make all these changes to your code or to your data, and then it synchronizes when you come back online. But another thing that people often overlook is that having sync is actually pretty cool, even when you're online. So if you didn't have sync and you were making API calls to a cloud or something like that, you would have to wait for the network round trip before you could be sure that your data was persisted. Or if your data is made it to the cloud. But if you have your local data, you can actually make these changes locally, treat all your data as if it's local, and then let the magic of getting to the cloud happen behind the scenes. And so your app becomes that much more reactive. You respond to changes right away, and every button press is persisted right away locally. And then the online bit happens asynchronously, which is pretty cool.
So I don't have to live in constant fear when I'm in a subway and I'm going into a tunnel and I'm not sure if that API request is gonna send, or my note is gonna get saved.
And as a developer on this, it's my biggest pet peeve when I get an app that doesn't work offline. If I'm in the subway and my game doesn't connect, or my Spotify, maybe I don't know if I should call out people, but if my app doesn't work properly when offline, it is the most annoying thing, because I'm like, just use this thing, it works. We've built it.
So I have a couple of questions here. Your product before the MongoDB acquisition was Atlas, right? That was the product that you used for syncing.
So I guess both Realm. So Realm had its own product. We had what we call Realm Sync, which were using Realm both on the back end, on the front end, and Mongo had their own mobile offering called Stitch. And then we just realized, hey, Realm is pretty good at the mobile side of things, and hey, Mongo is pretty good at the server side of things. Maybe if we just swap each other components out, then like things are working pretty nicely.
So that gave way to Atlas, which is a device sync.
Atlas is actually the umbrella term for all of MongoDB's hosted cloud offerings. So whether you're getting a database, like the MongoDB database hosted in the cloud, or whether you're using all of our app services, all of that's under Atlas. Without going too far into the naming of everything, we have Atlas App Services, which is this collection of things that let you build apps really well. So things like GraphQL endpoints, things like triggers, things like hosting and functions and stuff like that you can use to build your app. And we call that a backend as a service, where you don't have to write much server-side code, but you get an app. And then this particular product is Atlas Device Sync. So Atlas is a modifier for everything.
Right. So in regards to this, because one is a document database, another is an object database, object-oriented database. How do you make use of Mongo in these terms? I mean, is it just the underlying structure of syncing the data, or how do you do that?
Yeah, that's a good question. So you're totally on the money here, that it's complicated to convert data from different forms, right? Realm has a schema fundamentally, and MongoDB, we're looking at documents. And so we have a component on the server that, as it receives changes, has to figure out how to translate every single Realm write that we receive from clients into MongoDB changes, such that it ends up in a database. And what we can expose to customers is this beautiful interface that doesn't, give you or tell you any of this is happening, so that you can use MongoDB for your mobile data. And on your client side, you've got a strongly typed schema-aware system, but on the cloud, you have documents, and you can interact with MongoDB using all your existing MongoDB tooling.
And one thing, again, like I've not worked much with object-oriented databases, right? But when I see the code, for those folks that didn't listen to the code, I will now describe the code for you. There was some classes, and this segment's brought to you by Garden Eden gardening gloves for all your gardening needs. There was some classes with some annotations, like there was a primary key, right? So I look at this from a developer's perspective, and I don't necessarily care about the underlying technology. And you talk to me about lazy loading, which again, if I'm using a relational database with an ORM on top, object relational mapper, I can activate that or not activate that. So from the developer perspective of the developer experience, how is working with this different to working with an ORM that is, using a relational database?
So that is a very good question. So I would say the biggest difference is that in a relational model, the underlying sort of representation always leaks through much more heavily than in an object database, right? If you have a relational database under the hood, like representing just simple things like relationships are actually pretty tricky. Like exposing things like lists are close to impossible, or not impossible, it's very tricky. Exposing things like sets or maps are nigh impossible in a relational, like if you have to figure out how to create tables for all of that. If you have a object-oriented database, we have those data structures like lists, like references, like sets, maps, we have built those directly into the database. So like you don't have to think about performance when accessing those data structures, right? If you have a relational database like SQLite, anytime you sort of jump a reference, you have to think about, oh, am I doing a join underneath the hood somewhere? That is probably expensive. How like stuff like that. Well, what about my foreign key? Like there's a bunch of concepts you have to have in mind when doing that, when working with a relational database, even if you have an ORM on top, right? With Realm, all of that just goes away because we have those things are native to the database all the way to the storage layer. So that's probably the biggest difference, I would say.
And you default to lazy loading on anything, or that's something that the user can
No, so
define?
that's something we default we use everywhere. So basically, what we're doing is, so I guess it gets a bit technical right now, but like we are memory mapping the entire database, so it's available very quickly. So that means that while traversing relationships in a SQLite database requires some sort of join that is pretty expensive to do, doing that in Realm is basically just following a pointer in memory, right? So that is much faster, and that is also why we have things like infinite scrolling that is sort of building into the database itself, so that you can have your list of 1 million tweets and scroll through it without implementing stuff like paging. That is sort of giving to you for free, right? So there is a lot of really powerful things you get from using an object database compared to SQL, I would say.
Yeah, this actually, I have to say, this resonated with me quite a lot now because for a little bit of a side project, I'm using a Kotlin library called SQL Delight, which is kind of like quite the opposite. So for those of you who don't know what SQL Delight does, is it allows you to write like SQL code, so actual queries, and then it generates type-safe Kotlin wrappers from those. Which means on the one hand, well, you're not dealing with any kind of arbitrary like API that someone has thought up to do your queries because you're writing real SQL. But it also means that you're writing real SQL, which means that exactly those things. Like I was trying to implement some basic tagging functionality for a couple of documents that I was saving, and the amount of research I just had to do to kind of figure out, like, okay, in Kotlin code, this would just be a set of strings probably, or something like this. And now I need to have a table that's the relationship between the IDs of my actual entries of my documents, and then I have tags, and then do I just want to have an association directly, but then I'm not normalized, so maybe I should have another table which has IDs and tags again, and then I have like 2 joins for each request, and all of a sudden your little SQL statements that are looking so nice and cute, all of a sudden they're kind of exploding, and you're doing left joins, right joins, and then you're tasked with things like returning more than 1 tag for a document, and then everything just kind of explodes.
Yeah. And I mean, so, and then you see the same problem with both SQL, like both SQLite and libraries like Room are really great libraries, but they also they sort of work on the premise that you want to write SQL right somehow, and that's just not the case. In many cases you don't. Plus, that especially like the Room documentation has pages upon pages on how you have to model relationships, right? Which is just not something you want to care about when you want to ship your app doing something simple, right? You just want to, hey, I just want my set of strings. Please make it easy for me, right? So, but of course, like I guess that's the argument why people are sort of using SQL Delight libraries, is that a lot of people have learned SQL in the past somewhere, so they know sort of the language, right? So they might be aware of this. But if you're sort of not, like, it is a pretty big hurdle to get over.
So this is Kotlin Multiplatform. You target. I mean, Seb mentioned that he saw a bunch of things on the demo. But to recap, what platforms do you support when it comes to Kotlin?
So right now we support Android in all its variants. We support iOS. We support macOS. We support native iOS and macOS native. We support JVM platforms, so that's Windows, macOS, Windows. So we don't support specifically JavaScript right now. So it is something we're looking into, but obviously that is a bigger thing because then we have to run our database in WebAssembly in the browser. So it is pretty interesting, and it's definitely something we're looking into, but it's not there yet. But basically, we support what you would consider the primary targets. We could, in theory, also support things like Raspberry Pis with Linux ARM variants. So the only reason we basically don't right now is that we have to find a CI setup that actually tests the thing works on there. So, but like nothing prevents us from doing it, which is, I think, the really cool thing about having, now we have written the entire SDK in Kotlin and having being multi-platform aware, is that basically adding support for new platforms is just, it's not writing the code anymore. It's finding the way to set up the tooling around it, the CI with distribution. It's all of those things that are the road stops now. It's not actually making the thing work on those platforms.
Just for clarification, when you say we could probably run it on a Raspberry Pi, do you mean like natively? Because I would, or so if I have a JVM application, I mean, the Raspberry Pi can lift that if it tries really hard. Would that just work out of the box right now?
Yeah, that would work out of the box. If you have what is it called, Android Things, that would work out of the box. But if you wanted to compile for a pure Raspberry Pi, that wouldn't work out of the box right now.
So in your adoption of Kotlin multi-platform, what have been the biggest pain points for you?
So I would definitely say it has been the memory model, mostly because as a library, we had to sort of make sure we worked on both on the JVM side and on the native side. Like that was doable, but I think the pain point was that there was this there is this transition period where people are like, you just promoted the new memory model to beta, right? Which is awesome, which means that we can sort of push people there. But like before that, there was a bit of a pushback on some projects didn't really want to migrate to that, someone didn't. And as a library, we sort of got stuck in the middle trying to, okay, what should we do there? And this was especially a problem with a library like Ktor, which is like basically the default if you want to do networking, right? And we depended on Ktor in our backend. But that they sort of made the transition like some months back to the new memory model. But like, in order for us to support, they only supported that, right? So if we sort of adopted Ktor 2, which has that, we would basically force all the people using our library to the new memory model. So we went a bit back and forth on that. But now everything is beta. We sort of said, okay, let's do that. And then so we moved everything to the new memory model, which also simplified up a lot of our code. So that's where we are now.
And you mentioned Ktor, and be very careful how you respond here. Are you using Ktor right now?
Yeah. So we're actually pretty happy with it. So like it is very cool that you can sort of plug in these different engines depending on the platform and just have one API for configure them. That is, I would say that is very nice. So yeah. So we are pretty happy with it. So yeah.
That's great to hear. Wonderful. Awesome. Cool.
You can hear some people like exhale, being like, fine. We're not going to get chewed out by Hardy tonight.
That's so unfair. So I'm curious, when you were talking about conflict resolution, you said operational transformations. Did I hear that correctly?
Yeah, operational transform. That's right.
Okay, so can you explain what that is and how you actually like resolve conflicts in a situation where like one phone is offline and then goes online and says, well, you just made this payment through or whatever, like this ticket that you wanted to buy is no longer available. Like, how do you solve that?
Yeah, that's a really good question, and might take a week to answer, but I'll give you the short version now.
So,
the first thing to think about is, say that we sent the entire document or table row or whatever object to the server. That is actually it actually becomes difficult to resolve conflicts if we send just the new state of the object. What we really care about whenever someone makes a change is what the change was, right? Did you update a particular field? Did you append to an array? We're more interested in that change than the new thing that we created. And so one sort of counterintuitive thing is that instead of sending the new state, we send these sort of change sets, the instructions that represent the change that occurred. And so what OT does, operational transform, you feel free to read the Wikipedia article for a very technical, detailed overview, but on a high level, it takes any two changes and says, given these two changes, which one of these changes should I preserve and should I modify it? So you can consider if two of us updated the same field, in that case, only one of those should actually make it through because maybe the last write on a field wins. But if two of us appended to the same array, then both of those should stick around. But the order actually really matters, because if you insert it into array index 0 and I insert it into array index 0, depending on which order the system outputs those two instructions, we would get different arrays. Does that make sense? And
Yep.
so what the operational transform algorithm will do is just basically say, you, Sep, when you created these writes, what did you know about? In the world of all writes that occurred on this data set, which of them did you know about and which of them did you not know about? And if you didn't know about all of these, instructions number 10 through 20, and you're creating your own set of instructions, for every one of those instructions that are now coming in, we're going to have to compare them against all the instructions that you didn't know about and run this operational transform algorithm to output these mutated changes that are effectively what changes you would have made had you actually known about those things when you made them. And we do that for every single client and every single change on the server, and we output this like new rewritten history and then send that back down to the client. And here's where things get interesting. The clients actually do operational transforms as well on the mobile devices. And that is basically saying, well, I didn't know about those writes, and now these are coming in. So it does the inverse operational transform. And part of the guarantee of operational transform and why it becomes really fascinating is it guarantees that if I do operational transform on the server, you do operational transform in reverse on the client, we both end up with the same exact piece of data at the end of the day. And so that is a core premise that allows us to say, given the same set of instructions, different clients will converge to the same state.
I guess one of the also very cool things about this is that we work at a very low level of granularity. So like we can basically see changes to properties as changes, right? So if you have two devices updating different properties on the same object, if people are implementing this themselves, they would just take the entire state of the object, put it to the server, and the server would say, oh, one of these have to win for the entire thing. But operational transform basically see that, oh, you're just modifying two different properties, they don't conflict at all, so like that will just propagate to both devices, right? So one, it minimizes the amount of traffic we have to send, and two, it actually makes the combined set of changes more accurate. So
it means that, like, if you say you're building a to-do list app, right, a list of items that need to be checked off your to-do list, you preserve the end user's intent much better. So if one user checked it off and said it's done, and the other user said, oh, actually, I need to add a tag, or I need to change the spelling of one of the items in the to-do list. And if that's the same item, as Christian said, the naive way would be just to take the latest write. But because these are both operating on different parts of the same item, you end up being able to preserve the intent of each user. And so the end user experience is just so much better as a result of that.
I have a follow-up question on that, because, well, you mentioned this is kind of all based on operational transforms, and I have a good friend who's constantly in my ear, because that's something that he's kind of working on, which is CRDTs, so conflict-free replicated data types. I personally am not nearly deep enough into any of these shenanigans to kind of really understand the big difference in them. But I just wanted to ask you to comment on, whether there's a particular reason on why you preferred one or the other.
Yeah, that is something that I am not an expert on either, because operational transform was chosen before I joined the team. I can give you a quick overview of the main differences, but a lot of it was that it ended up being just a little bit better performance-wise. And the biggest one, I think, was that operational transform does a better job of preserving end user intent than CRDTs do. And so what I just described about, it's possible to have everyone converge to the same consistent state, But it's also really nice when that state reflects what you were actually trying to do in the first place. And operational transform tends to do a slightly better job of that. But CRDTs is something that we've considered. We've thought several times about using that in various parts of our system, and we've ended up sticking to operational transform.
It's essentially kind of like event sourcing, right? You are storing the intent of the user and what they're doing, as opposed to a state of the object, right?
I have a feeling that this 2-minute snippet on operational transforms versus CRDTs is gonna fuel about a 5-hour lesson for myself next Saturday when I hang out with this gentleman the next time. So thank you for that. I've got my weekend my weekend entertainment settled now, thanks to you.
Okay, Seb, we really need to talk about your weekend entertainment. Like, really? Okay. I got to take you out of it. Okay, you got to leave that basement, Seb. So on to very, very important things. I have one question. What is the business model around this product?
We like for you to be able to use things for free. And so you can actually get off the ground and start using Realm for free. And that's really nice. You can start building the local database. You can start using it in your mobile apps. It's entirely open source. Where you start having to pay is when syncing comes in. And so, like many apps, we've got a free tier. You can create an Atlas free cluster. But after your sync traffic exceeds some certain amount of minutes used and certain number of requests, then you are paying for two things. One, you're paying for the Atlas cluster, the cloud MongoDB server that is supporting all of your cloud operations. And then you're paying for the number of sync operations you do and number of sync minutes. And don't quote me on, I don't know the exact number in terms of dollars. Feel free to go check out the website, I guess. But it's pretty cheap. It ends up being like a very small fraction of a cent per minute.
Yeah, and that's absolutely fine and great. And in fact, I'm happy that you actually have, a model where you charge folks, because then it means that you have a sustainable business that can move forward, right?
Yeah,
So
I like it personally because it means that you can, you can build a fully functioning mobile app and not have to worry about paying anything. And you get the database, you get all the local stuff, and then later on, when you realize you want syncing for whatever reason, or you want your data on the cloud or something, with just a line of code, you can enable syncing, and then you start paying, and you start getting this server-side component almost for free.
Plus that the server side is also scalable, right? So you only pay for the traffic. So you basically only pay the more users you get as well, right? So yeah.
And have you thought about a Netflix model where you pay slightly less and then get advertising inserted?
Can you imagine we insert advertisements into your mobile app for you?
Every fifth row in your database is just a sponsored post.
It doesn't matter what the object is. We'll just accommodate it to some advertising.
Yep, this is your DTO, sponsored by JetBrains. I have to say, what I think is also just really cool is that you folks support desktop, because I know mobile is the big and shiny one, and everyone does mobile apps. But with Compose for desktop, since we now have more fun ways to build desktop applications, it's kind of really cool to see libraries where it fits like a glove, right? It's Kotlin itself, or it's native, and you could see sponsorship right there again. It's Kotlin again, and it kind of works well, and you're basing it on these ideas of flows and all of that, which I guess makes it really easy to integrate there as well, which I just think is really cool.
Yeah, so I would also say, like, we were actually like Realm is it was born in sort of a mobile first world, so that was sort of what our way of thinking. But once we shipped this multi-platform SDK, we were actually pretty surprised how many devices out there that are not mobile phones, but like you have your counter registers and you have your kiosk devices, you have like a bunch of really weird devices out there that are still some sort of small thing that people want to have syncing capabilities, right? So we have a bunch of people already show, oh, we have this thing running on our Windows kiosk devices, running around scanning inventory and whatnot, right? So yeah, that has been pretty fun to see that a thing that started out as a mobile SDK is actually like anything in this day and age is basically a device, right? You can hook into this, which is pretty fun to see.
it really seems that kind of communication code seems to be the thing that otherwise you have to spend so much time on, just getting data into your system and out of your system. So I'm always in favor of any product or library that helps me avoid that, so I can focus a little bit more on what I actually try to do.
And I would say, like, we did some measurements at some point just to show people how much code they actually write. Like, if you want to implement this yourself, right? And we saw like something like up to 30% of people's apps were basically REST code trying to pass REST API, send data, handle like being offline. All of this code is just something that really doesn't matter that much, and it's just annoying to write. So yeah, so plugging sync into that was just like, no, you can remove this entire part of your app. That's pretty compelling, I would say.
Yeah, at the expense of job security, because all of a sudden you can't bill 800 hours anymore for writing your little CRUD app.
Yeah, and to be honest with you, I'm a big fan of desktop apps, and I think it was a little bit insulting, though. I mean, I'm very, very excited about Composer Desktop, but it was insulting when you said, "Oh, a new fun way to write desktop apps." My friend, there was an awesome way to write desktop apps before you were even born.
What,
it was called Delphi.
Oh, okay.
And by the way, chief architect was Anders Hallsberg, who is Danish by that. If you don't know, he's now at Microsoft doing TypeScript and C#. So that's where I started with desktop and professional development. So I'm really happy for desktop. And anyone that says, "Oh, mobiles kill desktop," get the hell out of here.
Would you want to go back to Delphi?
No, I can go back to Kotlin for Compose Desktop, or Desktop Compose for Kotlin, or whatever. Anyway, right, folks, it's been a pleasure. We are past the time. We're going to have to wrap this up, and Seb and I is going to go back and do the sports commentary on your segment of live demo. So thank you very much for joining us. Folks that want to find out more, I assume they can go to realm.realm.io, right? Realm.io, or is it Realm.io? You don't know your own website. Okay.
Realm.mongodb.com will take you there.
What it says by mongodb.com as well. Yeah, but you're still there.
So Realm.io is basically the website for the local database. If you go to cloud.mongodb.com instead, that would be the sync side of things.
Okay, that's where people go to the cloud.
Yeah.
Okay.
Cool.
Thanks for having us. This was a lot of fun chatting about all the things we care a lot about. So thanks for your
time.
It shows that you care. All right. Well, thank you so much. Have a wonderful day still, and to all of our listeners,
it's 7. It's 7 o'clock. Seb.
Well,
I know you
zones,
have a weird time, but it's 7. Okay.
Yeah.
Go.
Okay. Anyway.
Continue.
Thank you for bringing me out of my concept. I always love it. You know where to go if you've been listening to this. If you want to see the demo of a couple of counters incrementing and decrementing, youtube.com/Kotlin, where you can see this episode again. If you're also listening to us, you probably haven't subscribed yet and have not hit the bell. I don't know if anyone still does this. I suspect the YouTube algorithm just does not favor you anymore if you add engagement thing. I don't know.
And make sure you hit the thumbs up.
Look at that. Give a thumbs up for Hadi's garden glove. All right. See you in the next one. Take care, everyone. Bye-bye.
Bye-bye.